In this video, we're going to discuss the advantages of using the innovative RFID Flex antenna for more accurate and controlled scans at choke points such as dock doors or conveyor lines. These top-performing RFID antennas are enabling scans at dock doors, conveyor lines, workstations, and logistics sites, which were not possible with legacy RFID antenna systems. To begin, let's review the two prominent types of legacy RFID antennas. We will see how legacy RFID antenna systems limit overall system performance by either scanning only select tag orientations or scanning more area than desired. The first type of RFID antenna we will consider is the linear polarized patch antenna. This antenna is ideal for long-distance communication and frequently used for radar and satellite signals. In the RFID world, linear polarized patch antennas are helpful for reading faraway tags when tag orientation is reliable and consistent. The primary disadvantage of using the linear polarized patch antenna to read RFID tags is that it will not scan tags which are presented in differing orientations. Think of the linear polarized patch antenna like a laser beam that has a very narrow view. The second type of RFID antenna we will consider is the circular polarized patch antenna. This antenna radiates in a corkscrew-like wave. While not reading tags as far away as the linear polarized patch antenna, the circular polarized patch antenna brings the benefit of reading RFID tags very well in multiple orientations. The primary disadvantages of using the circular polarized patch antenna to read RFID tags is that the corkscrew wave spreads to a broad area, making it very difficult to constrain the read zone, and the read distance is often shorter. Think of the circular polarized patch antenna like a floodlight that has a very broad view. The revolutionary FlexAntenna is purpose-built to solve the shortcomings of the linear and circular polarized patch antennas. FlexAntenna is a multilinear antenna design which combines the power and accuracy of multiple linear antennas to ensure RFID tags can be read in all orientations. FlexAntenna allows for powerful reads of all RFID tags while providing a constrained read zone. Looking at all three antenna types together, you can see that FlexAntenna excels in both reading RFID tags in all orientations and providing zone control to ensure you are reading only the tags in the desired area. Let's now look at a practical application where the benefits of the RFID Flex antenna help with successful project outcome. Here we have 3 pallets. Notice that the RFID tags are in varying orientations. Often, pallets and conveyor lines convey items where label orientation may not be guaranteed. Let's first look at these 3 pallets when centered in the doorway in front of the antenna. The first pallet with the tags parallel to the floor is captured very well by all 3 antenna types. The second pallet presents some challenges to the linear polarized patch antenna as the 45-degree orientation doesn't align with the plane of polarization. The tags are captured, but the received signal strength is much weaker than desired. The FlexAntenna and circular polarized patch antenna again capture all tags very well. The third pallet causes to the linear polarized patch antenna to miss tag, reads altogether as the 90-degree orientation presents a worst-case scenario for the plane of polarization. The FlexAntenna and circular polarized patch antenna again capture all tags very well. Now, let's look at moving the pallet by 1 meter offset from the center of the antennas. Looking at the first pallet, we see that both the FlexAntenna and linear polarized patch antenna begin to miss. Tag reads not directly in front of the antenna. The circular polarized patch antenna continues to read tags very well, even when off to the side by 1 meter. We see similar results for the second pallet when offset by 1 meter from center, though the linear polarized patch antenna misses more tag reads given the 45-degree orientation of the RFID tags. The FlexAntenna still reads some tags nearest to the antenna center, but not those furthest from the coverage zone. The circular polarized patch antenna continues to read tags very well as it is less sensitive to orientation and broadly scans past the confines of the doorway. The third pallet, when offset by 1 meter, continues in this pattern, where the circular polarized patch antenna captures tag reads and the flex antenna captures only those RFID tags still within the coverage zone. The linear polarized patch antenna remains unable to capture tags in this 90-degree orientation. Moving the pallets to 1.5 meters off-center, we see that the flex antenna stops reading the tags altogether. The circular polarized patch antenna continues to read tags even this far outside of the doorway, and the linear polarized patch antenna is only seeing some weak tag reads in the strongest red orientation. So why does this matter? Let's consider that we have an RFID system installed at a doorway to scan all boxes which are moving through the doorway. Using linear polarized patch antennas, the system will work very well if the tags are consistently presented in the correct orientation. However, if some or all of the RFID tags are rotated, the system will miss RFID tag reads. When circular polarized patch antennas are used, we eliminate the challenges with tag orientation, but now introduce a new set of challenges when controlling the read zone. Imagine a forklift carrying a pallet full of boxes is passing nearby the doorway. Circular polarized patch antennas will capture these RFID tags in addition to those that actually pass through the doorway. This creates problems within the system, as these boxes may now show as having left through the doorway, when, in fact, they are still in the facility. The RFIDKNOW Flex antenna reads the RFID tags in all orientations, which pass through the doorway, but not those passing outside of the read zone. The same is true for boxes on a conveyor line, where the circular polarized patch antenna will see not just the box centered to the antenna, but also the preceding and following boxes, if not spaced at significant distances. This may result in digitally encoding the wrong RFID tag or duplication of identifiers. If boxes happen to contain multiple RFID tags to form a kit or bill of materials, then the system may allocate some tags to the incorrect box. In summary, the RFIDKNOW Flex antenna is an innovative RFID antenna, purpose-built and designed to capture tags in varying orientations, while at the same time control the RFID read zone. Ideal for doorways, conveyors, workstations, and portals, the Flex antenna allows your RFID system to capture everything you want to see and only what you want to see. We hope you have enjoyed this video. To learn more about the RFIDKNOW Flex antenna or our other products, please visit our website at rfidknow.com or follow us on LinkedIn